So now let's understand fine tuning. So we have a language model, which is a pre-trained model. So that is a good starting point. We already have a pre-trained model, a pre-trained language model, right? So this pre-trained model, we will treat this as our foundation model. So this foundation model save us time and effort. So what do we mean by that? We will see it, right? So what we do is that there is a foundation model which is trained on the large amount of data, which is uncontextualized, right? Which is the data we use for the web, right? So like these large language models, or these language models are basically trained on data on the web and from other sources, but it's not trained on our specific data or anything like that. So they are trained on that data, right? But they are not trained for our specific task or our specific requirement. So what do we mean by that? So we could have a specific requirement for, that we want our responses in a specific format and in a specific tone of voice and in a specific style. So we have that requirement that we want our responses to be in this way, right? So like for example, our marketing department has said that the tone of voice is very crucial for the customer base, for our client base, and that's why we cannot compromise on that. So that's why we want our responses to be in a particular tone, right? In a particular format and style. So if we use our pre-trained model, then the pre-trained model are good for the starting point. So like our pre-trained model will not give the responses in the style and format that we want, right? So for that, what we could do, we could basically train our own model. We don't need a pre-trained model. We will train our own model, but that will cost us a lot. We will waste a lot of time, a lot of effort, and a lot of cost. So that is not a proper way to do that. What we will do instead is we will take a pre-trained model, right? That would be our starting point. It has already learned a lot of general concepts and a lot of things it has already learned, right? So we will utilize that. We will take the pre-trained model and then we will basically fine tune it. So this pre-trained model will be our foundation model. We will not train it from scratch, and this will save us time, effort. So what will be the benefit of this fine tuning? So the fine tuning's benefit over training a different model, training a model from scratch. What is the benefit of fine tuning? So we will use less compute and less time and less data. So we would require a small amount of data compared to the data on which this language models are trained from scratch, right? So we will require less data, less compute, and less time, right, to customize our model. We will just customize our model. We will not train it from scratch. So that is the benefit of fine tuning, right? All of these resources we are saving on it, and we are still getting our the specific format, style, and tone of voice which we want, right? All of this is basically what we want. So this is what fine tuning is. So this is a very nice diagram. So it's tell us the difference between context optimization and model optimization. So context optimization is basically what the model needs to know, right? So we so the model does not know about our company document. Model does not know about our model product catalogs, right? All of these documents are very specific to our company or our shop, right? So if the model wants to know that, so prompt engineering and RAG will help in that, right? So in RAG, we basically put the part of the document in the query. That's how it's basically getting the context. Model optimization is a totally different thing. So model optimization is how the model needs to act. So it's basically telling that what kind of responses the model should give and what are the patterns in the request and responses. So it's basically the behavior of the model. It's not the data it knows, it's basically the behavior of the model. So that is model optimization. So when we want model optimization, we will go for fine tuning, and when we want context optimization, we will go for retrieval augmented generation. And prompt engineering sits in between, and it's not really good context optimization or really good model optimization, but we have some techniques in which we can basically mimic or like have a parallel with both of these. So let me explain this. So first of all, let's understand RAG. So the core concept of RAG is that we are augmenting knowledge, right, at query time. So we are not touching the model. We are not training the model in retrieval augmented generation. What we are doing is we are taking the specific relevant data and putting that in our query with our prompt, right? So that's what all we are doing. So we are just augmenting knowledge to the model. So we are just giving the additional knowledge to the model based on which we can give the response. We are not touching the model or training the model. So what are the advantages of RAG? So the advantages of RAG, it like if we compare the RAG and fine tuning, so advantage of RAG is that it provides us up to date external knowledge. So it, it might happen that you have a company policy and you basically trained your model, or you fine tuned your model on that company policy. But after an year or after 6 months, you know your company policy changed and now it's totally different. So now you have to train it again, right? And that costs a lot. That is a lot of botheration, and that is a lot of resources wasted, because this is a kind of data which is keep on changing, right? So we always need to know the up to date information. So training your model on that data does not make sense. So it is good for dynamic data. So dynamic data is a data which keeps on changing, or which will keep changing frequently, right? So in that, if the data is of that kind, then RAG is the best choice because it provides us up to date external knowledge. We can change our knowledge base without touching our model, right? Knowledge base can be updated without touching or training the model. So this is the flexibility that retrieval augmented generation gives us. Then the next advantage is for external and proprietary data. So some of the data like customer history or internal company documents, right? We do not want that data to be the part of models training data. So because we don't want that, in that case also RAG will be a better choice. Then yeah, the advantage is that it reduces hallucination, and it also helps in citing sources, like which source, because it is retrieving that source, so it could also cite that resource for the given answer. So these are the advantages of RAG over fine tuning. Disadvantages that we have to store embeddings and there is a retrieval cost, and for every query this retrieval things happen again and again, so it decreases the performance because there is a latency to latency to query things before we can, there is a retrieval step latency, so we have to retrieve the document and afterwards we are sending uh, that augmented prompt to the LLM. So this creates a latency and that's why it decreases the performance. So that's the disadvantage of RAG approach. So now let's look at fine tuning. So if we understand what's fine tuning, so fine tuning is basically, so we have a pre-trained model. We are continuing its training of the pre-trained model with our domain specific data set. So we need to have a domain specific data set and we will continue the training of the model, the pre-trained model. So we are basically uh, training our pre-trained model on our domain specific data set. So from the data set, model can learn patterns, behavior, terminologies. All of this model is learning and the weights are getting updated. So the actual weights of the model are being updated in case of fine tuning. And it is based on the data set. So you should be really careful about like what kind of data set you are bringing to basically train or fine tune your model, right? So the dataset, what a typical dataset might look like, you might have 1,000 examples of input and output pairs. So input and output pairs basically your prompt and response, what kind of response you want and what is the prompt. So you can train on that. So we are not just providing the information like we are doing in RAG. We are telling the language model how to process the information, that if this kind of query comes, then the response should be in this format, in this tone, right? So it's not just the information. It's not just a company documents a particular paragraph. It's we are telling him what would be the response for the specific query. So we are telling him to how to process the information. So that's a difference here in fine tuning, right? So model learns to recognize domain specific patterns. So like it understand what kind of patterns are there. So like for which kind of request my response should be what kind of style or what kind of tone. So that is what model is learning. So in which cases fine tuning is better? So in deep domain expertise, so like if you have a complex reasoning like within the field of medical or legal, so in that cases you need a deep domain expertise. So in that case you can use the fine tuning. Static domain specific knowledge, so if your data is static, right, it does not change so the frequency of change is very low, right? So in that case you can also use fine tuning. And another advantage of fine tuning is that it is faster than retrieval augmented generation, because at the inference time you do not have to search for the external data, and you do not have to maintain a separate database, separate search index for retrieval, right? All that retrieval augmented generation process has not been performed in fine tuning. So every time you put a query, it just goes to the language model and it gets a response. So that is one of the advantage. uh, and the disadvantage, so disadvantage is training is very complex and there is a lot of compute cost, and then you need to maintain and update it if you want to change it frequently. So that is also one downside. And the another is catastrophic forgetting. So catastrophic forgetting is what we mean by that is that some of the general capabilities that our base model had, it forgets that while it is learning the specific capabilities from our training data, right? So that is also one of the disadvantage. So now let's see the parallels between few shot prompting and fine tune model. Remember that I told you that prompt engineering also does a little bit of model optimization and context optimization. So with the help of that, we can also do a little bit of model optimization and context optimization. So let's understand that how prompt engineering, with the prompt engineering, we can do a little bit of model optimization. So in prompt engineering, we have this concept of few shot learning or one shot learning, right? So it's basically with the prompt, you also give an example of the request and response. So if I put this request, then this should be a response. So you give the examples of that. So that is what we mean by few shot learning. So it uses small number of examples within the prompt to guide the pre-trained model. So that is what we mean by few shot learning. So the advantage of this is it is very fast, cheap, and less data, but it's not that accurate, right? Even if you give examples, it is not guaranteed that LLM adopt to that certain style or format, right? Or a tone in that response. So although it's fast and cheap and you just need 2-3 examples in your prompt, which is less data, but it's not accurate and it does not guarantee a consistency in the responses. And fine tuning, so in fine tuning you have a large specific data, right? You just not just 2-3 examples, you have a large specific data on which you train your model weights. So you change the model weights, you are not just putting them in the query, you are retraining the model and changing the weights. So of course this will be time consuming and expensive, but it is more accurate. So you get a consistent responses, and you adopt a certain style, format, and tone in the responses, and you have more accuracy in your responses. So if you want to improve the consistency of model behavior, fine tuning base model works, right? So if you want to you want a consistency from your model, so fine tuning the base model will work. So that's what we understand by what's the difference between fine tuning and retrieval augmented generation, and where we could use what are the use cases of that, right? And how prompt engineering relates to both of these. So yeah,